Hello and welcome. In this lecture, it's all about physics constraints, and we're going to be learning what a physics constraint is, why we're going to need it, and we're going to create one and figure out how to make them and why they're useful. So if I go ahead and play this, you can see that one cube has fallen down slightly, and if I move this other cube, boing, 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 it is being constrained to the position of this left cube within some margins. So it's not falling down completely, but it is just just able to jostle about a little bit. It doesn't happen in the other dimensions, just in this Z dimension. And we're going to be looking at how it can also constrain things like rotation and so on. So let's dive into the lecture and see how we can create this. So, a quick reminder, in the last lecture we came up with this springed wheel vehicle as our model, and we had these wheels attached to springs which are attached to the main tank body at the top here. Now, what we need is a way of making sure that these wheels move relative to the body in a way defined by these springs, and also that they only rotate on their axles. And both of these things are essentially what we would term a constraint. We want to say that this wheel moves in a certain way but not in other ways, and that the spring behaves in certain ways but not other ways, so that it can compress, but it will exert a force when compressed and things like that. Now, in Unreal, the way to express these sorts of things is with a physics constraint. Basically, this communicates that constraint to the PhysX engine underlying it. That's a library by NVIDIA which underlies Unreal. But we don't have to go into too much detail because all we have to interact with is the physics constraint. So let's have an introduction to what the physics constraint is, and particularly we're going to be using a physics constraint through a physics constraint component. There is also a physics constraint actor which allows you to make constraints between two actors. The physics constraint component allows you to constrain two components. So we're going to go ahead and create a little test bed for this. So I'm going to go over to my content browser, and you can follow along with me. I'm going to go into my levels, and I'm going to add in a new level by right-clicking and hitting level, and I'm just going to call this spring test bed, like so. And we can go ahead and open up said new level, and it's going to be completely empty because I've created it as an empty level. So let's put a little few things in here. First of all, I want to put in a sky light. So I'm going to look in the modes panel and bring in a skylight. Then I'm going to want to bring in a directional light. And I'm probably going to want a skybox as well. So I think this BP sky sphere, there you go. So we've got a sky sphere, some lights, some directional lights. In fact, I could probably change the angle of the directional light to get a bit of a less moodily lit sky sphere. Then I can go onto the sky sphere, and I think I can refresh the material or something like that. I think I might have to rotate in a different angle, or rotate, sorry, the light I think is what we need to rotate. So it's facing downwards, and then go to the sky sphere, update, refresh the material. Okay, that's not really working, maybe because I need to select a directional light. Yes, there we go. Okay, so now it's giving it a little bit less of a moody look, which is good. And then finally, I want to go into the geometry section of my modes pane, and I'm going to bring in a box which is just going to be the basis for our pawn to land on, and I can go ahead and change the size of this box. I'm going to go 1000 by 1000. Oops, that's 100. 1000, and then the Z doesn't matter too much. In fact, let's make it 10,000 because I always forget this is in centimeters, so that's going to be a nice wide terrain. If I go ahead and hit play, here I am, I'm a pawn that can go around over the top of this terrain. That's a great test bed for us to just be trying things out without everything else going on. So I'm going to make sure that is saved. And the next thing we want to do is go ahead and add a new actor. Now, where am I going to do this? I'm going to do a new folder called experiments. And then in the experiments folder, I'm going to go and add a new blueprint class. It's just going to be an actor, make it really simple, and I will call this the constraint test, like so. And we can go ahead and open up that blueprint. Now, what I want to do is show you how we can set up a very basic constraint. So go into Add Component and look for the physics constraint, which is a physics constraint component. or a UPhysics constraint component if you're looking at the C++ API. And we are going to be using that later, by the way. And then we can go ahead and add some very basic components. In fact, I'm going to go ahead and just create some static meshes. So I'm going to create the mesh A, and then I'm going to add a second mesh, static mesh, and it's going to be mesh B. Let's have them all at the root, because what I want to show you is that they will move together even though they're at the root. So let's attach them both to the root. And then we want to connect them. So we go to the physics constraint, go over to the details pane, where there is a constraint category. And in there is the constraint bone, but also the constraint name of the component 1 and component 2. If you expand that out, then we can type in mesh A, and the other one is going to be, funnily enough, mesh B. And obviously, if you've got a skeletal mesh, you can actually constrain to a particular bone so that you could have your character hanging by their hand or by their neck from something like a noose, for example. And that could be quite a cool effect. So we've got these meshes set up now. I'm just going to give them something that we can actually see. So if I select both meshes, I'm going to go to the static mesh portion and then select a static mesh for these mesh components. And the mesh I'm going to look for, let's see if I can just find something, cube, nope. Ah yes, if I go to view options and select show engine content and then look for cube, then there should be some cubes in the engine content. So if I select a cube like this, there we go, I've got myself 2 cubes. And what I want to do is just show you what this physics constraint actually looks like if we have these 2 meshes slightly apart. So let's move them apart. Then you can see that there is this constraint here. And when you click on it, you can visualize the constraint. And you can see how it's basically this red and blue line going from the constraint to the constrained object. And you can see these outlines are boxes, but those will always be boxes no matter what the shape is inside. That is just a simplification of that visualization. Don't worry, the collisions will still be treated as whatever the collision volume is on that. So what's happening at the moment with this constrained thing? Well, let's have a go. Let's put it in our world and see if we can visualize or try and explain what's going on. So I'm going to just lift it above the ground, go ahead and hit play, and sure, not much actually happening here. Now the reason for this is these boxes are not simulating physics. So if we go ahead and select both meshes and go to simulate physics, compile and save, and go over and hit play, there you go, they both fall to the ground. Not very helpful, but if we F8 out of here, maybe we can select the boxes and see if we can move them independently or something. Let's try that out. So I'm not getting a movement widget. There you go, it's all the way up here because the components have fallen down independently. And if I go and move them around, nothing happens. Okay, so I think we need one of them to be simulating physics and one of them not to be, so we can move it around. So if I select A, and A is going to be kind of our static point, the one that I'm going to move in the world, and then B is going to try and follow it, or whatever the constraint is going to do. I'm kind of giving the game away, aren't I? Okay, here's an interesting thing. So by default, this constraint is acting a bit like a hinge. So it is hinging around that constraint point, and the one that's not simulating physics is staying put, but the one that is acting under gravity is getting pulled down. So if I go and move around the top one, you can see that we can use it to swing the other one around, and it is free to move in any old dimension that it wants, just like this, boing, 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 which is quite fun, but obviously not what we're trying to achieve with the wheel, nor what we're trying to achieve with the spring. So I'm interested in seeing how we can play around with the constraints properties to get different effects. So getting it moving in one dimension is going to be the challenge for you, to tweak the limits of a constraint and to be able to figure out how to make it constrained in different ways than just this kind of hinge that we've got. So that's the challenge, to play with the constraints, and there's 3 particular outcomes I'd like you to come up with. The first one is, can you get them fixed? So by that I mean, can you get it so that when you move the stationary one, the other one just comes with it and is basically fixed in its relationship, as if you'd attach them, but without actually attaching one to the other, without childing one to the other. Can you get them rotating like a wheel? By this I mean, can you get it to rotate only around one axis, but not around the other two axes if you've got three axes of rotation? And finally, can you get it moving in one direction, not rotating at all, but moving in one direction, sort of like a spring? The wheel goes up and down in the spring's arch, but in the spring's direction, but not moving left or right or forwards and backwards, but only up and down. Can you get these three constraint setups? Pause the video and have a go. Okay, welcome back. So let's try fixed first. This should be fairly straightforward. Going over to the constraint test, let's open up our physics constraint and look at the details pane and see what properties we can play with. So we've got our constraint behavior, not much here. We've got linear limits. Now, linear limits sounds interesting, but maybe for later. Let's come back to that. Now, there's angular limits. Now, if you think about this, this is saying, how do we limit the rotation, essentially? The angular, the angle, that should get you in mind of rotations and things like that. So we've got a few interesting terms here. We've got swing, 1, 2, and twist motion. Now, these terms are a little bit confusing, so we will dissect them slightly. So you can see, if you zoom right into the constraint, you can see that there's this little orb, and this orb is kind of telling us what constraints or range of motion we've got with our limits. So if I selected locked on all of them, you can see that all of them go away. If I select free on just the twist motion, you can see that it's going to twist around this sphere. And in fact, let's give this a go. Let's go just do twist motion on its own. Going to hit play and F8 out. And I'm going to try and rotate around, get it rotating. There you go. It is rotating around basically that sphere, or that sphere that we're seeing. In fact, we've just achieved that wheel-like motion. If you think about it, it's off-center, so it's a kind of wonky wheel with an axle in the wrong place, but it is a wheel-like motion. It's just rotating about one spherical angular dimension. So that's great. We can go ahead and stop the simulation. And what we want to achieve is where we locked all of these. So they just move together. Go ahead and hit play. Then, sure enough, I hit F8 and move them around. Yep, not moving anywhere. That other cube is lagging a little bit behind because that is the nature of physics simulations, so they're not 100% perfect. They are not 100% perfect, but it is moving with and not rotating in any which way. So we've achieved 1 and 2 now. What remains to be seen is how we can get them to move in just an up and down axis. Let's stop the simulation again and go back to our physics constraint and go to this area that says linear limits. Now, what I'm interested in is you've got X motion, Y motion, and Z motion. So I could set them all to free and see what happens there. If I go ahead and hit play, then boom, it goes ahead and just falls right down to the ground, and there is no position constraint to it whatsoever. So if I F8 out and move around, nothing's happening. But interestingly enough, I think if I rotate it, yep, sure enough, there's still a lock on them being in the same orientation. So that hasn't gone away. They're not completely unconstrained. They're just not constrained in position in what is known as the linear limits. So what we want it to do is to just move in one of those dimensions. I'm going to choose the Z dimension so it can fall to the ground. Go ahead and hit play. There you go, it falls to the ground. Sure enough, and if I move my cube around in any of the other dimensions, it follows with. It can go up and down freely, but along the X and Y, it is following with. So one more thing for us to understand about constraints is that they aren't either free or locked. There is a value in between, which is limited. So if I said Z motion is limited, then I can say how much give I'm allowing it. So I'm going to give it 1 meter of give, or 100 centimeters of give, and hit save, and go ahead and hit play. Now our cube falls, but not all the way down. So if I F8 out, you can see that between the constraint, there is now this green line, which is the amount of give. And if I jostle it around, you can see that the red line goes between the maximum and the minimum of that give line. So it can just bounce between these two values. And we can see how this is already starting to act a bit like a spring. Not quite, because it's just resting basically at the top of the spring. But we can get this a little bit better with something called linear drives, and velocity drives, which I'm going to be talking about in the next lecture. Cool stuff. So let's briefly recap what you have learnt this lecture. So after this lecture, I'm fairly confident that you should be able to create your own physics constraints between two components, set them up that way, figure out which needs to simulate physics and so on in order to get something interesting happening. And you can play around with setting angular limits and linear limits and constraining them in different ways using the twist and the other things that we had in there, the swing and twist, that's the ones, and the X, Y, and Z constraints. And you can play around with that and really get a good sense. Hopefully the challenge gave you a very good sense. And yep, I will see you in the next lecture where we'll be diving even further into the physics constraint. See you there.